Hello everyone, I am Srisha. I am from CSC AML Department of Section D. Today's my physics tech talk topic is void space and interstitial space. So let us move on to the topic. Void space. Void space refers to the empty space present in between the particles or molecules or ions in a solid structure. The region inside a crystal lattice that is not occupied by any molecules, particular ions or particles are called void space. So this is the definition of void space. And here we have some example, that is, in a closed packed structure, there will be only 74% of space occupied by spheres, sphere-like structure, also indirectly called atoms. Remaining 26% is void space. Void is nothing but empty space. And the importance is it determines the density of the solid. So we will say the density of the solid depend upon the void space present in the required atom. And it affects packing efficiency, and it explains why some solids are lighter even with a heavy atom, even with a heavy atom structure or atom density. So these are some examples and importance of void space. And next we are moving to the interstitial space. Interstitial space refers to small spaces or gaps in between the molecule or particles or ions where another atom or ion can fit. So the definition itself says that it is the gaps in between closely packed. There are two types of interstitial space or voids, that are tetrahedral voids and octahedral voids. We'll discuss about these types later in our further slides. Now let us move on to the topic examples. So we'll take one example. So in an FCC or HCP, there will be a structure with 4 octahedral voids per unit cell and 8 tetrahedral voids per unit cell. And this usage will be helpful in small atoms like nitrogen, lithium, nitrogen, and carbon. So, properties. It is harder and stronger than pure metal. It has a higher melting point, often used in tools, machines, and construction. So, examples for interstitial compounds are steel, ferric nitride Fe4n, and titanium hydride TiH1.7, and boron carbide B4C. Formed from steel formed from mixture of iron, carbon, and ferric nitride, iron plus nitrogen. Similarly, titanium hydride, titanium plus hydrogen, boron carbide, boron plus carbon. So these are the alloys. We can simply say that interstitial compound alloys. So now we'll discuss about the types. In our previous slide, we have discussed there are two types of voids. There are tetrahedral voids and octahedral voids. So tetrahedral void. A tetrahedral void is a small empty space formed when the particular atoms, particles, or ions are arranged in a tetrahedral shape. So, how it forms? Similarly, three atoms form a triangle at the base. One atom is placed above the center. The empty space between them is the tetrahedral void. So, in this, we will be having a place of repulsions and valence bond theory, etc. Key points. It is very small in size and its shape tetrahedral. In an FCC or HCP structure, FCC is nothing but phase cubic center, the number of tetrahedral voids is equals to 2 into number of atoms. For one atom, there will be two tetrahedral voids. Next, coming to octahedral void. An octahedral void is a larger empty space formed when an atom or ions or molecules surrounded a central empty region. So now we'll see how it works and how it forms. There will be four atoms and it forms a square shape. One atom above and one atom below the square. The empty middle part is the octahedral void. Here, the empty space between them is a tetrahedral void, and here, the empty middle part is octahedral void. This is also one of the major difference between tetrahedral and octahedral void. So the key points here is, it is larger than tetrahedral void, and the shape is octahedral, and in the FCC, HCC, number of octahedral voids is 1 per atom, and for one atom there will be only one octahedral void. So now let us discuss about packing efficiency. Packing efficiency is the percentage of space actually by atoms in a crystal structure. And the formula given for packing efficiency is volume occupied by atoms by total volume of unit cell into 10. So the values for common structures are mentioned. So now we'll see higher packages, higher packing efficiency, atoms packed, and more tightly, higher density. This is the proportionality, where higher packing efficiency more, then the atoms packed is more. If the more tightly, there will be higher density. So now we'll see the packing efficiency of each and every structure. So that is simple cubic SC, we have packing efficiency of 52%, and for BCC, body center cubic, we have 68% of packing efficiency, and for face center cubic, we have 74% of packing efficiency, and for hexagonal closed packing HCP, we have packing efficiency of 74%. Here we have packing efficiency more in FCC atoms and HCP atoms. And in simple cubic, there will be least packing efficiency with 52%. So the difference, now we'll see the difference between void space and interstitial space. So the features, coming to the point features, we have void space, interstitial space. In void space, empty region not occupied by atoms. Whereas in interstitial space, we have specific voids that can hold small atoms or ions. And in size, generally void space is empty space, but in interstitial space, it defines geometric gaps with like tetrahedral or octahedral, like that. And in coming to the occupancy point, void space contains usually empty, but interstitial space can be filled by small atoms. In rule, void space determines packing efficiency, whereas interstitial space helps from interstitial compounds. These are some major differences between void space and interstitial space. So, till now we have discussed about what is void space and its definition, example, importance, and what is interstitial space, definition, and the types of interstitial space. There are two types of interstitial space, there are tetrahedral and octahedral, and we have saw some examples here, and the properties of both some interstitial compounds, and we have thoroughly discussed about tetrahedral void and octahedral void and some key points, and we have also discussed about packing efficiency and the packing efficiency for SCC, BCC, FCC, and HCP. And we have the major difference between void space and interstitial space. So we all know that void space have usually in meaning, in size or occupancy, it is completely empty. But whereas in interstitial space, it has some geometric gaps and shades, and also it can be filled by small atoms. So these are some main differences which differs void space and interstitial space. Thank you.